right, folks, welcome back. Today we're hanging out at the Cornell Tech Center on Roosevelt Island in Manhattan. A beautiful place that's been under development for several years, almost 5 years or so. I'm John Belizaire, CEO of Soluna, and today I have with me Ari Jules, who is a professor here at Cornell. He's also the co-director of IC3, which we'll talk about what that is, and he's also an advisor to the company. And there's an interesting thing about our location. We're actually at the Cornell Center at this weird, I don't want to disparage, at the MIT Incubator called MIT Delta here at Cornell. How did MIT be hanging out at Cornell Center?
Yeah, I have no idea. I wasn't aware of the existence of this facility until I met you here today.
So today we're going to be talking about a lot of things. Sometimes you're going to be talking to us as the professor responsible for teaching this new exciting technology. Sometimes you're going to be talking about the co-director of IC3. And sometimes you'll be discussing things as our advisor, which we really appreciate you assisting us. So let's dig in. Before we get started, it might be helpful for you to introduce yourself a bit, Ari. Folks perhaps don't know your background. How did you get here?
Well, I was in industry for a number of years at RSA, which is a security company, now a division of Dell. It's gone through a number of acquisitions, direct and indirect. I was there for about 17 years, most recently as chief scientist, and ran RSA Labs, oversaw RSA Labs as the director. So I was overseeing the applied research program there.
So they had a research program focused on cybersecurity, I would imagine? Or?
Focused on cybersecurity writ large, including things like applied cryptography, for instance, yes.
Where is RSA now?
Their headquarters, at least last I knew, is in Massachusetts.
Right. I've driven by the building a lot in Bedford area.
Yes.
It's where my last company was based, not too far from there.
Okay.
Most of the time was because the driver was lost. I'm like, oh, here's where the RSA building is.
Yeah, there are only a couple of reasons to visit Bedford. One is to visit RSA, and other is because you're lost. Yes.
Right. And so from RSA, did you go directly into academics, or did you do consulting after that?
No, I went into I joined Cornell Tech after leaving RSA.
Got it.
Yeah.
And what's your focus of academics here at Cornell Tech?
Well, for the most part, I'm focusing on blockchain-oriented projects, and the reason I like blockchains as a topic is that they sit at the convergence of many different disciplines within computer science.
Right.
So it's a very rich area for exploration as a researcher or a practitioner. Touches on applied cryptography, programming languages, game theory,
network effects, all that kind
of
stuff.
Networking, and of course there are also relevant non-technical disciplines.
Right.
We have in IC3 a legal scholar and 2 faculty from the business school who are also quite interested in the topic.
And why is that? Why legal topics?
Well, smart contracts in particular, as you can imagine, are relevant to the legal profession, and they're unlikely to supplant attorneys anytime soon. I think perhaps a better term for the technology is business logic automation.
Right.
Smart contract, I think,
it's kind of like it's a sexy term. It's all about it's smart. It's a contract,
right?
And it sort of imputes the fact that it might replace other ways to do contracting, right?
Much more alluring term,
right?
Yes, but also less accurate, as alluring terminology tends to be
in marketing.
Yeah.
So did you know you were coming into a blockchain program when you just came in, or was it something else and sort of transitioned to blockchain?
Yeah,
blockchain is fairly young. Well, relatively speaking.
It is, though, I'd consider myself a veteran. I was doing work in this area as far back as 4 years ago.
Wow. Yeah, that's a long time.
Well, actually, in
the tech space,
in a previous life, I did work on eCash and related topics.
Okay.
proof of work as well,
Yeah.
and so on and so forth.
Have you read that book, Digital Gold?
No, I haven't.
It's a pretty good book, actually. It chronicles the entire sort of blockchain, Bitcoin development. Really focuses mostly on Bitcoin, and introduces the concept that it sort of started with eCash, and it also provides some conspiracy theory about who Satoshi Nakamoto might be and whatnot. It's actually a pretty good book, and I think Netflix made a movie that, I don't know if it was based on the book, but it's sort of like also about the whole Bitcoin, and I think they call it sort of digital cash, or betting on Bitcoin or something like that. And I watched that, and it was sort of documentary style, and it chronicles everything from the networks to the criminal activity that led to the sensational discovery of this interesting technology.
I mean, there's so much cinematic material here. I'm waiting for movies.
Yeah,
on the topic to come out.
You gotta get. I could be your agent. I could probably place you in a couple movies.
Well, so I first was introduced to the topic of eCash at a conference called Financial Cryptography. I went the first year. It was 1997, I think.
Right.
It's now sort of degenerated, if you will, into a pretty mainstream academic conference. But that first year, it was extremely colorful.
Really?
So I was sitting on the beach, for instance, with a colleague of mine from Bell Labs, and some guy comes up to us and says, "You're wearing trousers. You must be nerds. You're at the conference, right?" And then proceeded to plop himself down and explain that he was interested in eCash because he saw in it a way to plant the seeds of the demise of the U.S. government and launder money and so on and so forth.
That's amazing.
Yes, and there were other similarly colorful characters there.
See, that could be an episode right there. It's a new blockchain series,
But you're asking how I got into, or what I was doing when I first came to Cornell Tech, and how I got into blockchain research. When I first came here, I came as I've considered myself an applied cryptographer, did some research in other cybersecurity topics. But I first started exploring blockchains in earnest in 2015, I guess it was, when a colleague of mine introduced me to Ethereum and smart contracts. And my first question to her was, this all seems very interesting, but what are they good for?
Right.
We spent an afternoon scratching our heads. It was really hard to come up with compelling applications. But then finally we hit on it. The killer application, which was crime.
Crime?
Yes, crime.
As a general category.
So we realized that smart contracts were perfect for all kinds of criminal activity. This was pretty worrisome to me. Bitcoin was already being used for ransomware and purchase of all kinds of illegal goods through the Silk Road and so on and so forth.
Yep.
And I saw in smart contracts an opportunity to amp up this kind of criminal behavior in the medium to long run. I didn't see this, and I don't see this as a short-term risk, but it's something we need to pay attention to. So the first paper I published, on blockchain technology, as it were, was a paper entitled "The Ring of Gyges," a classical illusion, and it described ways that smart contracts could be used for crime.
I see. In
the digital realm and also in the physical realm, what people are calling meat space these days, right? As a warning to the community, to urge people to think seriously about the downsides of this technology. And I've since come to believe there are a lot of upsides as well. And happily, colleagues at the Ethereum Foundation are aware of the potential abuses of the technology, and I think reflecting deeply on countermeasures and ways that the community can police itself responsibly. But that was my introduction, as it were, to blockchains.
And so you started digging in even further and sort of built a whole program around it, essentially.
Yes, so we recognized that there were a number of faculty at Cornell and Cornell Tech and some colleagues at other universities like UC Berkeley interested in the same topic. We decided to join forces and try to catalyze both cross-campus collaboration and interdisciplinary collaboration by creating an organization whose mission actually is to bridge the gap between academic research and industry need.
Right.
So one of the wonderful things from my perspective about blockchains is that they have created a close connection between academic research and industry practice, a much closer connection than has historically held in, well, any area of computer science.
And do you think that's the nature of the technology, or is it because the blockchain have such a need to find a legitimate application?
Well, there's a good side to it and a bad side.
Right.
And the bad side is that many people are just learning to or looking to make a quick buck and see an opportunity to commercialize, responsibly or not, academic research. The positive facet to all of this is that people have realized that a number of technologies that have lain dormant, in some cases literally for decades, are suddenly relevant again.
Right.
So there's a wealth of material just waiting to be mined, if you'll allow the use of that term.
Yeah.
Waiting to be mined by the community.
Right.
And academics have become very excited by the prospect of seeing their discoveries used in the short to medium term.
Yeah.
And I just love it. I mean, it's also just wonderful, makes for wonderful educational, pedagogical material. I co-taught a blockchain course this past semester where we had students doing hands-on work, and actually I taught 2 courses. In one, they were exploring ICOs, critiquing ICOs, and
from a technical perspective, or sort of business viability?
From both a technical and a business perspective. And the opportunity to see things unfolding in real time and to be able to critique these ventures in meaningful ways was, I think, very inspiring to the students, and some of them have gone on and
done some projects of their own.
Right.
Yeah. That's cool. As is the whole goal and focus of the Cornell Tech program.
Yes, indeed.
So tell us more about IC3. So I understand it to be a consortium to some extent of industry research, actual blockchain projects themselves, or any projects involved in that?
Well, so we have 16 faculty spread across 8 campuses in 4 countries. Most of those faculty are computer scientists, but as I mentioned, we also have a legal scholar, 2 faculty in the business school at Cornell. And we have a number of industry partners with whom, in some cases, we work hand in glove developing new blockchain technologies. Now, as I said, the goal is really to take advantage of the close connection between practice and academic research. So we have twice annual retreats with our industry partners. Just last week and the preceding week, we had boot camp we are holding on an annual basis with the Ethereum Foundation up in Ithaca.
What's the boot camp?
We're doing hands-on projects, translating research into prototypes.
Into actual prototypes on a particular blockchain, on the Ethereum blockchain?
Yeah, these are Ethereum-oriented projects. Cool. We had some of our industry partners represented there, a bunch of faculty and students. So the goal, as I said, is to take advantage of this close connection.
Right.
And our research is sort of loosely organized under the banner of 6 big technical challenges that we refer to as our 6 grand challenges, which I can enumerate if you like.
So I before you do, I guess I want to sort of maybe talk a little bit about why the focus on the grand challenges. I mean, you've got if you look at the blockchain ecosystem right now, you have cryptocurrency networks, you have new blockchain projects specifically focused on a particular application. You're now seeing sort of tools to support the development of coding on these blockchains, and obviously there's all sorts of different business models. And there's lots of keen interest about the future role that blockchain can play in the world. How does one go from all of that excitement to, hey, there's all these issues with it? Like, where is that bubbling up from?
Well, it's a somewhat chaotic process. I would say that every faculty member's group has its own particular bent and expertise. These groups work together, come together on particular projects. But project ideas can come from almost anywhere. Yeah. Okay. It can be just a spark of imagination on the part of a student, or it can be an observation by a faculty member that there's a pressing problem in a particular domain. This is what makes research so exciting. You have no idea where the next idea is going to come from. Yeah.
So walk us through the 6 challenges then. What's the first one?
Well, the first, and the one that most people are familiar with, is the challenge of scaling and performance. Today, blockchains, particularly the permissionless variety, have very low throughputs. And the maximum transaction rate of Bitcoin at this point is something like 7 transactions a second. And, the Visa payment.
Very often compared to Visa.
Right. That's the common point of comparison.
And Visa does how many transactions?
It's, I think, on average something like 2,000 a second, and it can handle much higher peak load. Well more than an order of magnitude larger than that.
And it's a distributed system, but a centralized approach to the implementation, obviously.
Right.
Yeah.
Right. So you're paying a pretty heavy price for the decentralization of trust in these systems, and the question is, can we improve their performance to the point where they can compete with global transaction systems like the Visa network? And there's certainly reason to believe that we can improve their performance considerably. Whether they can remain secure in the sense that they are today, while supporting transaction rates, 2 orders of magnitude or more higher, remains to be seen. People are pursuing a variety of approaches, from different consensus algorithms to what's called sharding, partitioning of the blockchain.
Do things like Lightning Network fall into that category? Or
right. Yes,
and example of scaling.
That's another approach to scaling, to do off-chain transactions with the blockchain acting as a mediator. Yeah, and there are a bunch of other approaches as well. So that's the first challenge, and that's one that I would say at this point a majority of researchers, both academic and non-academic, are primarily tackling today.
What's the second one?
So the second challenge is confidentiality. The beauty of blockchains is that they provide transparency.
Right. I was well, yes, but also confidentiality as well. It's sort of a transparent opacity to some extent.
Well, no, that's the problem. They don't provide opacity, right? Okay. So the downside to transparency is that it's essentially inimical to confidentiality. And so the question is, how can you achieve the two simultaneously? How can you ensure that transactions are executed correctly, while ensuring that sensitive data isn't leaked by merit of the fact that these transactions are happening on the blockchain? And this is a really hard problem, actually.
So cryptography or just sort of obfuscating information isn't sufficient to do that, or?
No. So, even take encryption, for example, right? Yeah. So you can certainly encrypt data on chain. Yeah. But then you can't, at least not without impractical heavyweight crypto, you can't compute on this information, right? So you can stick encrypted data in a smart contract, but then what are you going to do with
numbers
it?
Because
right. So it turns out you can actually add 2 numbers under the covers, as it were. You can do a certain amount, and there are very sophisticated techniques, sometimes referred to as spooky moon math, zero knowledge, which can be helpful in that you can do things off-chain and prove that you've done them. You can prove knowledge of particular information, as it were, and correct execution of programs. But even that doesn't quite get us there. There are certain things that zero knowledge can't do. It can't conceal secrets from the entity that's creating these proofs, for instance, unless you add even more sort of heavyweight apparatus. And also, it's not terribly performant. The performance is improving, but it's always going to be much slower than direct computation. So another approach that people are taking is use of trusted hardware, which also has its pros and cons. You know, I'm a big fan, but there are security issues with trusted hardware. It leaks information through side channels, as they're called, and so on and so forth. So this remains a big technical challenge as well, and it's one that I regard as absolutely critical to smart contracts' broad adoption. The approach taken by much of the industry today is basically to avoid the confidentiality problem by not putting any data on the blockchain.
So they keep everything off-chain, essentially, which kind of defeats the purpose. Right?
Yes, exactly. Right. So you lose a lot of the transparency if all you're doing is taking your data and or
just
your
moving
transactions
on the blockchain.
Yeah, you're just
indirectly, if you will. Yeah.
Yes, exactly. So the approach is basically to hash the data, put the hash on the
blockchain,
and then the blockchain.
Say, hey, we're on the blockchain. So.
Right. And then you're on the blockchain. I mean, you're still getting something meaningful. To be fair, you're time stamping transactions, for instance, in a highly reliable way, but you're losing a lot of the benefits of blockchains that way.
Right.
So this also remains a big technical challenge.
I want to talk a little bit before you go to the next few. There's been lots of talk about just sort of blockchain in general, and you alluded to the fact that the original application was, criminal enterprises and whatnot, and there's lots of talk about what role the blockchain will play in, future society and ecosystems and whatnot. What's the most exciting thing you've seen in your time working on, blockchain research and technologies that sort of points to a future application that's not criminal in nature?
I was going to ask, not crime. Okay.
Yeah, crime is not allowed.
So many of the applications people propose for blockchains don't make a lot of sense to me. I've never understood the use of blockchains for maintaining electronic health records. For timestamping transactions, yes. For some limited purposes, yes. But I think many of the
and you don't think that's a good idea? Why? Because of the whole privacy thing, or?
Confidentiality remains a concern, but there are other challenges as well. Blockchains are not great for storing bulk data. If you want to put radiological images on a blockchain, for instance,
it's not really designed for that, if you will.
Right.
Yeah.
Right.
That's disappointing because I was really looking forward to that. I hate the fact that I have to go and I got to go get my records from one doctor, then I go to another doctor, and he's like, "Have your doctor send the records." Like, what do you mean send them? He's like, make a copy and send it to him. So I literally take pictures of all my medical records, and believe it or not, I keep it on Evernote, and I just walk to the doctor and say, it's right here.
Yeah, you're basically maintaining your own electronic medical record
system. Exactly,
right?
Which is kind of annoying.
It is, yes. And I think there is an opportunity for blockchains to help hospitals coordinate their operations and maintenance of data.
Right.
But one has to recognize that this is going to happen in a fairly limited way unless blockchains evolve to the point where they can actually store massive amounts of data.
Right.
That's not likely to happen in the short term. And there are many other applications that don't make an awful lot of sense to me. But there are a few that I think are fairly promising. One of them, for instance, is creation of new types of financial instrument. Right? This is something that smart contracts are already realizing. And I think blockchains, with a few major challenges addressed, correctness being an important one, as well as confidentiality, of course. And that smart contracts are going to enable people to create a whole new host of financial instruments. And this will impact not just...
What do you mean by financial instruments? You mean stocks, currencies?
I think we'll be creating financial
securities?
instruments that don't even fit into existing categories or buckets. But yes, new
Tokenizing of, you mean the concept of tokenizing real assets, that sort of thing? Or?
Tokenization of real assets is an interesting possibility, and fractional ownership of art is becoming a trendy idea.
Yeah.
New forms
What does that
of...
even mean, by the way? Like, how do you fractionally own like a painting or a photograph or something like that?
Yeah, so I can only give you a layperson's perspective, but I think you treat the piece of art like a corporation or a condo or anything else for which fractional ownership is common today.
Interesting.
So you get $1 worth of a Gauguin or something, and
but then what do you do? Like, you can't put $1 worth of Gauguin on your wall. Like, look, I have this is the corner that I own or something.
It's a splendid way to debase the kind of spiritual value of the art.
Yeah, exactly.
But
this whole ownership for use, and this whole concept of is very interesting.
But I think actually there is
I guess if the piece was born digital, like it was created, with this notion that it would be owned in that way, maybe it'd be different. Maybe the problem is we're thinking of like current art versus future art. Maybe
that's certainly true. But even when we're talking about physical object,
right.
Ownership means a lot to people and their enjoyment of physical objects in the world.
Right.
The sense that you partially own a great work of art, I think, could actually enhance your enjoyment of it.
Right.
In a way that a more distant relationship to the object would not. So it may, in many cases, undermine the spiritual value of works of art, in that it turns them into investments, but at the same time, it gives people a closer connection. So they're very interesting. They're pros and cons.
What are some others? One more.
So another that started thinking about, talking to some colleagues in industry, is sharing economies.
Mm-hmm.
In particular,
Which category? Cars, homes?
Yeah, all of it.
Yeah.
Right? So if we can create new forms of financial instrument, if we can tokenize or fractionalize ownership or use of objects, there's the possibility of using physical goods in a much more efficient and ecologically sound way.
Mm-hmm.
And that's pretty appealing as well.
Yeah.
You're operating in a setting, of course, in sharing economies where trust between individuals is important, but the trust of an organization administering the sharing economy platform may be low. So
I see.
Blockchains
so
can help
way to
here.
Do that. Right.
Yeah.
Another idea I've read about that intrigues me is this concept of tokenizing land, things that people find difficult to turn into capital, especially in developing countries, let's say, for example. So if you could establish some provenance on a piece of land and tokenize that, you could use that to establish some sort of debt connection to it. There can be fractional ownership of that you can administer. Have you seen that at all?
Yeah, I've not looked much into tokenization of real estate, although or land, although that's a very popular topic. But I would say that another very promising application of blockchains is land title. So the majority of the people in the world do not have access to secure
title of their land,
of the land that they use or live on, and this is a real impediment to economic growth.
That's right. That's what excites me about it is if you could build, this global sort of land registry, if you will.
Yes.
You could lift a number of people out of poverty because they could now establish provenance, the fact that they own the site, they've been on the site, and that can be used to establish capital, right?
Right. Yes. So this idea is very appealing.
Mm-hmm.
The country that's sort of been in the forefront here is Sweden. It's land titling agency called something like the Lantmäteriet. I'm not going to attempt to
Don't even try to botch that name.
Yeah,
exactly.
I'm sure I've mangled it. Have been running a pilot, which I think is on the verge of, or has just gone into production mode, of a blockchain-based titling system. And I think the intention is to use it not just in Sweden, but to make the technology accessible elsewhere.
Right.
And that could be a real stimulus for economic growth, around the world. So that I would also consider another major potentially powerful application for blockchains.
Got it. So let's go through the other grand challenges quickly.
Right. Yes. So, all right. The other ones. Let's try to breeze through them.
Yeah.
So another is correctness, and in particular the correctness of smart contracts. So as I'm sure
the code, like finding bugs in the code, like what?
Yeah, the correctness of the code.
Oh, interesting.
All the way down to the bytecode. So that, as you know, bugs have been exploited in smart contracts to the point where thieves have made off with tens of millions of dollars from individual contracts. The DAO, of course, is the most famous example, but there have been others, Parity, Multisig Wallet, and so on and so forth. It turns out that creating correct smart contracts is hard, and it's hard for a number of reasons. One reason is that we don't have really good programming languages today. Solidity, which is the most popular, is very hard to work with.
Right. I understand you almost have to be a rocket scientist to use that thing.
You have to be more than a rocket scientist to write a correct program. Maybe a rocket scientist just to write a program. So that's one obstacle. Another is that it's hard to write a correct smart contract when you don't have a crisp definition of what correct means.
Right. There are no blueprints or frameworks. It's all new, right? So
it's right. The technology is new, and in formulating individual smart contracts, people often don't write down formal specifications. So the specification, the ideal behavior of the smart contract may reside only in the head of the developer, in which case it's going to be fuzzy, and what gets realized may or may not correspond, and the notion of correctness that the developer has may or may not correspond to that of the users. In the case of the DAO, the creator, Slockit, declared that the contract that people were agreeing to, signing on to, in participating in the DAO was the code itself.
Right.
And well, the code had a
bug,
right?
Yeah.
So you can ask, as people often do, was the DAO actually hacked, or was somebody just complying with its terms in a creative way?
Interesting.
But in any case, defining and achieving correctness turns out to be very hard, and this is a problem that we're pursuing in a multi-pronged way.
Got it.
So that's another of the grand challenges. Yet another is what to do when invariably your attempt to create a correct smart contract fails, right? And you've got a bug in your smart contract.
Yeah. What do you do?
Some
I was just
unforeseen eventuality.
Right. What do you even do about that? Do you communicate to those participating in a smart contract, and what's the oversight of that? Like, who sort of is responsible for mediating that? That's a whole new world, I would imagine. It's
very challenging. In the real world, we have a variety of legal mechanisms and constructs, judicial system to deal with contract failures. The automation that's so appealing about smart contracts is also problematic, in that it means that errors propagate automatically. And the terms of a contract can't be changed, essentially by definition, which is both a feature and a limitation. Right? It's a feature in that you know exactly what you're getting, but it's a limitation in that you can't change what you're getting. And flexibility in contracts can be very important and is enshrined in contract law. So the challenge here is to enable contracts to execute in such a way that bugs can be dealt with after the fact, but can be dealt with in a principled manner. So you need to build in some form of flexibility, and the question is, how do we do this? And that's not just a technical question, of course. Right? There are legal and business facets to this question. Right. That too remains a serious challenge.
Right.
So that's I think I'm through 4 challenges. Let me mention the other 2, which we may quickly actually end up consolidating into one because they're very closely related. So another is getting reliable, authentic, real-world data to smart contracts. It's bridging the gap between blockchains and other digital systems. Basically, smart contracts, for a variety of reasons, don't have internet connections. But any interesting smart contract needs access to real-world data. We're talking about a financial smart contract.
To your point earlier, you can't store massive amounts of data on the contracts on the blockchain.
Right. You can't store massive amounts of data, and even if you could, you want fresh data.
Right.
So how do you ensure that smart contracts get reliable access to fresh data? That turns out to be a hard problem, and this amounts to constructing good oracles, as they're often called.
Got it.
But an interesting related problem is creating good interfaces between blockchain systems and legacy systems, as we need a migration path from existing deployed systems to this newfangled technology. This sounds like a really mundane problem, but it could end up being pivotal. If existing institutions and industries are going to embrace blockchain technology, they're going to be able to need to do this in a gradual way.
That makes sense, yeah.
Yeah.
Especially if you are going to, a lot of the applications are either trying to replace or enhance current capabilities, and so there has to be some connection to previous applications, call them legacy systems, if you will.
Right.
Pre-blockchain systems, if you will. Right. Yeah.
Right. Yeah. This is super important.
Interesting.
And also, as it turns out, technically challenging.
Okay. So we're coming close to the end of our time. So I'm gonna do something here. I'm just gonna call it a lightning round. Okay. I'm just gonna send you a bunch of different questions, and you got to answer them really quickly.
Okay.
Ready?
Shoot.
What's your perspective on the energy problem created by the blockchain, and what do you think are the top 3 solutions for that?
Yeah. So I think it's pretty abhorrent that Bitcoin is consuming as much electricity as it is, more than a small nation, and this I think is just not sustainable. But people are looking at a number of different approaches. Wearing my Soluna advisor hat, I do think that investing in green energy and using blockchains as a stepping stone to the development of green power is an important approach. Another very important way to address the problem is through scaling. The more transactions a blockchain can process per second, the less energy per transaction it's using. And then new consensus mechanisms, I think, are going to be of central importance. They help with scaling, but they can also alleviate energy consumption by doing away with proof of work.
Right.
So at the moment, we don't have a real battle-tested alternative. Right. There are many promising ideas like proof of stake, proof of storage or space. There are a number of promising alternatives, but none to date has the kind of field testing and years of continuous use that proof of work has. We need to get proof of work out of the picture.
Got it.
And that's obviously going to be very important to alleviating the waste of resources that permissionless blockchains are responsible for. Now, permission blockchains don't have this problem, and in many cases may suffice.
And so that was going to be my next question, actually. I call them public versus private blockchains, but which one do you think wins out, public or private?
I think both have their place.
You think there'll be very large public networks that evolve over the next few years in the blockchain ecosystem?
I mean, in general,
other than the cryptocurrency ones, right?
Yeah. I mean, in general, I'm probably more bullish on private blockchains. They don't achieve the kind of decentralized trust, which is a powerful proposition that systems like Bitcoin do. But for many purposes, they're probably adequate.
Good enough.
And
enough decentralization to be good enough for their applications, what you're saying?
Yeah, that's my suspicion.
Do you think large walled gardens like, let's say, Facebook, Twitter, those kind of things will be replaced by blockchain equivalents?
I think it's going to be hard to replace them entirely, in part because truly decentralized management of data is a huge technical and even social challenge.
Right.
So I don't see that happening anytime soon. Elements could be replaced by blockchains, and identity management in particular.
Yeah, I was going to say.
Yeah.
What components would you say? So you think identity?
Even that is hard to achieve.
Yeah.
But I think there's some promising approaches.
And if you were to make one sort of parting comment about the blockchain, what would that be? What excites you the most about it?
I think what excites me the most about it is, believe it or not, the attention it has drawn to technologies that people weren't aware of in the past. But blockchain is a very broad moniker.
That covers a lot of underlying technology, right?
Yeah, but some people, some people use the term blockchain to mean trustworthy database. Others use it to mean applied cryptography.
Right.
So you can project whatever technological fantasy you want onto it.
Right.
And so I think it's stimulated, it's created newfound interest in a variety of different areas of computer science, and that's pretty exciting. Also, its interdisciplinary nature is exciting.
If we can get broad applications to just about anything.
Yes, it does.
Yeah.
So we can get computer scientists working side by side with financiers and legal scholars and so on and so forth, and people looking to do good for society. That too will be exciting.
Very exciting. Well, thanks for taking the time, Ari. Pleasure.
My pleasure. Thank you, John.
Thank you. All right, folks, that's it for today. Thanks for joining us, and we'll see you next time.